So let's bring this all together. The electrons are found inside orbitals, and the orbitals can carry a maximum of 2 electrons inside. We resemble this to the rooms inside flats, inside floors, inside the building. So it's inside an orbital, which is inside a subshell, which is inside the shell around the nucleus. The set of orbitals of the same energy is called the subshell. So all orbitals of S or all orbitals of P or all orbitals of D is called a subshell. The first subshell that we should know, there are the types of subshells. The first subshell is S, and you can find S in any shell, starting from the first one. The second one is the P subshell, and this one you can find it starting from the second and more. So anything in the second and up, while here you find it in the first and up. The third subshell is called the D subshell, and this one you can find it starting from the third shell and up. And the fourth one is called the F subshell, and this one you can the F subshell you can find it from the fourth and up shell. All the orbitals inside the S have the same energy inside the P, inside the D, inside the F. The different subshells don't have the same energy, the same way the different shells don't have the same energy. One of the most important laws of physics is that the matter is stable with the lowest possible energy. If the energy is very low, then the matter will be stable. This is the same way that this is the nucleus, and around it is the shells in which you can find the electrons. Just draw it as circles right now to explain our idea. But we have known that it's formed as orbitals, subshells, and shells. When all electrons are in the lowest energy level or energy orbit, which means that it is very close to the nucleus, the atom is said to be in its ground electronic state or the ground state. This means that there is no lower part where the electron can go to. It's not up here in a higher energy level, it's in its lower state. So we call this the ground state. For example, the hydrogen has only one electron, and the electron is in the hydrogen atom usually moves in the n1. We said that the n means the principal quantum number 1 or the energy level or the shell number 1, which is the first shell, the innermost and the closest to the nucleus. This one here, it will have the lowest energy and it's called the ground state. If the atom receives energy from an outside source, it is possible for the electron to move to an orbit with a higher n value, so a higher energy value. Instead of being in n is equal to 1, which is the first shell, it's gonna move to a higher shell, so n is equal to 2 or n is equal to 3. We call the atom now to be in the excited state, excited electronic state or the excited state, as it moves to an orbital or an energy shell with a higher energy. When it moves from an excited state back to the less excited state, the amount of energy that was in difference is emitted as a photon. So let's imagine it went from here to here up, and now it wants to go back to its ground state again after the end of the day. So this amount of energy that was absorbed and caused the electron to move from the lower energy level or lower shell to the higher shell now will be released outside of the atom so that it goes back to its ground state, and it will be released as photons. Same way we have seen the floors here divided into flats and rooms are the orbitals where the electrons stay. We can label the orbitals by letters. The first 3 orbitals are called according to the shells. So we have shell S, P, D, and F. Let's remember that we said the S subshell or the flat contains, which is found starting from the first plate contain only one orbital. So there is only one orbital inside, and this orbital can carry a maximum of 2 electrons. We'll draw 2 arrows like that in 2 opposite directions to represent the electrons spinning in opposite directions, as we will explain. The p subshell contain 3 orbitals. They all have the same energy, and we can draw them as boxes beside each other like that, with the same lines also, showing the opposite direction or opposite spin electrons. In case of D, this subshell contains 5 inside it. So if we have drawn a 5 orbital like that to represent the subshell of D. So let's draw 1, 2, 3, 4, and 5. And in the case of F subshell, it contains 7 orbitals inside it. To always imagine the subshell as a flat and how many rooms are inside this flat. So 1 room in the S type of flats and 3 rooms in the P type of flats. It's like you are having a building, and this building contains different flats like 2 bedroom, 3 bedroom. So the flats of the type S subshell contain 1 orbital only, 1 room, while the P contains 3 and D contains 5 and the F contains 7. So let's imagine the 7 bedroom or the 7 orbital. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And as you can count, since every orbital can carry a maximum of 2, then we can draw 2 into 5. So this subshell has 5 orbitals inside it. So it can carry 10 total electrons, while this subshell contains 7 orbitals, so it can carry a total of 14 electrons. The orbitals that have exactly the same energy, because they are in the same shell, like this one, the 3 orbitals of P, which by the way are called Px and Py and Pz, or the 5 orbitals in the D, or the 7 orbitals in the F are called degenerate orbitals. The degenerate orbitals are orbitals which have the same number or the same energy.